Okay, so sorry about that. Just had to pause quickly. So anyways, so on the static text display, so what you got here is you have the function light LED, and it takes in two parameters, unsigned ints. So ID is just a character array, and you're taking the element of this number. Now, I'm pretty sure LED is just 0, so player win. So player wins either 0, 1, 2, or 3. In this case, it could be up to 5 or just up to 1, or 7 or 11, or whatever number anyone wants. So then what you do is, so you have this, yeah? So let's say for at the very beginning, when the wins are both 0, what it does is, it goes to this character array, and as it shows there, the first element, or the 0th element, is 0. So that'll just print out this number here, which is, what do we call it? 38 in ASCII. Hold on, sorry. Just gonna pause the video. Okay, so, yeah, what do you know? 48 is the ASCII of 0. So if we go back to Code Composer and go to where the function is called, so here we are. So what this is actually doing is, since this is 0, it's getting the 0th element, which is 48 in ASCII, and then subtracting it from 48 again, which gives 0. And then this is the exact same thing, except the only difference is they're using two different variables, so they're independent variables. So this could be 1, this could be 0, this could be 5, this could be 30, whatever. And then, so the function it's calling is light LED, so then we go down to light LED, the actual function. And here we are. So, two parameters, as usual, are the two unsigned integers. And I have this big lookup table of 37 elements. Now, as it says here in the comment, holds the values of 0 to 9 and A to Z. So yeah, you have, so basically from all the alphanumerical characters. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you have A, B, C, D all the way to Z here. Now actually, there's this one here, 0, 0, 0, which is supposed to print a blank, but I don't actually use it because the string I'm printing out in the, where is it? In the moving text is just Connect4, there's no spaces. I'll move on to that later though. So let's go back here. So call light LED, and it puts in whatever. Because what we said here was it has 48. So when it's 0, it's 48 minus 48. So 0 and 0 at the beginning. So it's actually putting in the number 0 into the function. So we go here. This is just something to say if it's text, moving text or static text. I'll explain it later. And it's to have shifter lookup. So it's just the array. The array is called lookup, wherever it is. Lookup, yeah, int lookup. So lookup of LED num and LED num2, and this is LED num2. And remember, it's 0 and 0 in the first case, because the player wins are 0. So it's doing lookup of 0 and lookup of 0. So they both have these numbers in them, these hex values, 16-bit. Then you go to a shifter function, which is actually explained in one of the embedded systems code, but I'll explain it again. So basically you have these two values, int val1 and val2, just the names. So basically this is the one on the right, or the green, this is the red player. So you have the row, so this assigns the row. So from 1 to 5, whatever, because this is a 3 by 5 character. So then what you do is you have val1 equals val, remove all the bits except the last 3, and then assign those last 3 to the to the row, which is determined by this value here, b, and then light it up, and then shift by 3 to go on. So I'm just going to draw it out actually. So this is the drawings. So this is actually one of the embedded systems things. But anyways, so let's say for this character here. Now this isn't a number, it's a character. But if you can notice, it's actually the letter U, because it has the U pattern on this 5 by 3 display thing. So this is how it works. You get a 16-bit value. So this is the first digit of the hex value, because it's 4 bits of hex. So this is the first one, second one, third one, fourth one. And if you look back at the lookup table, again, you have 4 digits. So as you go back down to, sorry, missed it, to here. So now it's being called. So what it does is, gets that 16-bit value and divides it into 5 parts. Well, 6 parts really, but the 6th part is this thing here, the 16th bit, and it actually discards it completely. So what you end up with, so this is for the letter U, you have this, first 3, second 3, third 3, as in 3 together, fourth 3, and fifth 3. And what you get out of that is, you'll notice that, so this is 101, 101. That's the row. Sorry, that's the columns to light up. 101 again, 101, 101, 101, 111, 111. So what this is actually doing is, it's stacking these on top of each other. And the way it does is that counter here called B, which assigns the rows, is just giving this one a row, this one row number 2, or row plus 1, plus 1, plus 1, plus 1. So it stacks them up. Anyways, that's the stack, the text display. And literally the only difference between the two things is one of them is not shifted, the other one is shifted. So you'll notice one of them is on one side, the other is on the other side. So anyways, now moving on to the moving text, and I called it text shifter. Now, the differences between this function and the other function is that, well, first things first, is only one input called val, unsigned in, same thing, just whatever, 16-bit value. And then same thing, int b, which is for row assignment, as I've written it here. Val1, val2, storing values, or what did I say, used for comparison? Yeah, same thing. Int s. This value s is what shifts, is what moves the text across the screen. So look at the thingy. The text, is static in the other one, 3 by 5, but you need another variable that changes in value, that keeps moving, like this, So that's what the s value is for. You have val2 equals val. This is important because you want one unaltered val, or the parameter. You want to keep a copy of it that's unaltered. So it is a while loop here, while s is smaller than or equal to 3. It's from 0, smaller than or equal to 3. Again, this row setting thing. So first things first, set the val1, remove everything except the last 3 bits, shift it by 5. This is to move it, because I think by default it starts on the left, but you want it to move from right to left, since it's easier to read. Well, it's actually impossible to read it the other way around because you're reading it backwards. So yeah, then you have this thing called s, and this is what actually moves the text. So this thing moves it to one side, and s is what lets it keep moving this way. So then you have BGR of this thing, so it sets the value to that row, displays the row, and then shifts the entire row, not just the bits, the entire row, moves it by 1. And then moves the val2 by 3. So this is so this is new, because as well, notice how in the other one, there was, I'll just go back to it. In the other one, it was actually clearing, over there, it's actually clearing the BGR and then printing, because since it's static, you don't need to keep anything on record. But here you want to keep everything showing, because you don't want to lose the data. So you shift it by 1, keep it, and then increment s, and it's within the while. This is the for loop ending there, the while ends there. Sorry. And here's just a delay to show the text moving, otherwise it'd be too quick. So when you power on the MSP, you notice on the thing that the text moves. And it's quite simple. It's just that you need to get these right, and this, and this. I don't know if there are other ways to do it, but these seem to work. Now, I think it's the final thing to show, the final thing to demonstrate, is the 7-segment digital circuit. Now, while the video is paused, I set up the circuit. Now you can kind of see it. Now again, this is a Euro board circuit. Looks really ugly because, well, nothing's hardwired. Funny enough, it's pure flying cables. Oh, look, now it's it says E. That is, it shouldn't be doing any of that. So I'm just gonna explain the code. So actually, I'm just gonna pause the video and open multisim as well, just to show it there. So here's the multisim schematic. I made this in multisim, and how it works basically is you have an 8-bit shifter, an ANDed input. So this is your input here, your clear, your clock, and this is your 8-bit parallel output. So you have a serial input for a parallel output. Now, this came to me as an idea because, well, on the actual MSP board, I didn't have, actually I'll see if I have the PCB with, yeah, here it is. So on the actual PCB, I have these two test pins called receiver and transmitter. Now, I'm not going to connect this thing to a Bluetooth module. Well, I don't think I will anyway. So I knew that these were extra pins I could use. So I decided I'll design a circuit that displays 7-segment values, displays two 7-segment values using just 2 pins. So let's go through it. So the thing is, after you have the 8-bit shifter, you have this pin here, which is, as far as I can remember, oh yeah, sorry, it's obvious, it's the BCD, binary to decimal 7-segment converter thingy, the 4543 BD. I read the data sheets of both of these. They happen to work well. I just had to read up on, how to actually implement all this. But anyways, I pulled it off finally. And I, of course, I have these LEDs as well, just to show. So I'm going to start the simulation, just to show. And I'm actually going to show how the actual circuit works. So we have here input, and we have clock, and clear. We're not going to use clear, because clear, if we look at them, I'm going to press the clear switch, just clears everything. So it's pretty useless, unless we really want to just reset. But resetting the power will do that anyway. So we have input and clock. So this is how it works. So you set the input to whatever you want. So let's say we want to do the number 9. So we set to high and then clock it. And you'll notice the LEDs received it. And we said we wanted the number 9. So 9 is 1001. So we turn off the input and clock it again, and then turn on the input and clock it one more time. So pulled off the clocking, where we have 1001, and what do you know, it displays 9. This one is 0 because, well, there are 8 bits, so we have to share it as well. So let's just do 9 again. So clock this, clock it, and clock it again. So 9, 9. Magnificent. But anyways, so that's how it works. It's simple, but anyways, let's clear it now and turn off the simulation. So that's multisim really. So if we go back to the code, it'll now make sense. So we have so first things first, int void 7-segment, so it doesn't return anything. Int condition, so it's just an integer value, 1 or 0. Well, that's how I set it. I could have done it better, where it takes in a whole 8-bit value, but time limitations. So it is volatile onside long delay. It's just a delay. P1 directional, so it's setting the what is that? 1, 2, 3. Yeah, pins 1.0 and 1.1 as outputs. Yeah, and then setting P1 out. Yeah, setting P1.0 as high. And then what it does is, depending on the input, so if you wanted a high, it would see the condition is high, so the set P1.1. Yeah, P1.1, because this is P1.0. Set P1.1, and then after that, you clock it by toggling P1.0. Yeah. This doesn't matter, because it's going to take a new value in anyway. So you can just set P1 out as high and then back to low. And then that's just a little delay. So if we actually look at how this function is implemented, we'll just scroll all the way to the top. I hope it's still there. Okay, it's gone. I'll just program it quickly in. Okay, so I programmed it in. So what this does is hopefully, if I didn't get any of the pins wrong or anything, this program should actually register serially put into the the 8-bit shift register 1001 1001, displaying 9. Now this board here, I only put one 7 segment because literally all there is to it is putting another chip, but the problem is you don't really need it to prove a point because this is just showing that it is done. So anyways, I'm just gonna actually interface everything together, power up the MSP, and hopefully we'll see the number 9 on the display. So I'm just gonna pause now.